6.7, the last lesson in Unit 6, and it involves writing our equations again, but without a graph. So we look at problem 1. A group of students is tracking a friend John who is riding a Ferris wheel. They know that John reaches the maximum height of 11 meters at 10 seconds, and then reaches the minimum height of 1 meter at 55 seconds. Determine John's height at 78 seconds. So as you can see, I've gone ahead and I've already pre-labeled our grid here. Distance as my dependent variable, time as always independent, going up by 5s on the bottom, going up by 1s on the top. So once we have our grid labeled, I'm going to put in the 2 points that they give us. So a maximum height of 11 meters at 10 seconds. So at 10 seconds, we're at 11 meters. So I'll put a point there. And then the minimum height of 1 meter at 55 seconds. So 55 seconds there. And that's all they give us, is 2 points. So I guess the first thing we probably should do is connect those 2 points. Now we know, because it's a sinusoidal function, we're not drawing a straight line, right? It's not going to be linear. So we're going to try to give it a bit of a curve here. So it kind of looks something like that. So what we have is John at the top of the Ferris wheel, then at the bottom. Well, in order to complete one cycle, or one revolution, one trip around the Ferris wheel, he's got to make it back up to the top. So if we start at 10 to 55, it takes him 45 seconds to get from the top to the bottom, which means it would take another 45 to get from the bottom back up to the top. So 55 plus another 45 takes us to 100. And then we're back up to the top at 11 meters, right? Because we go from here, and then we go another 45 seconds to get back up to the top to complete one cycle. So we connect those kind of like that. And now we have one complete cycle from the top of the Ferris wheel back up to the top. Now it asks for the height at 78 seconds. And if we look at our graph at 78, so there's 80, so 78 is somewhere around, we'll say here. And I go across, I'm looking at just under 5, say 5.8 or so meters high. The problem with that is that I drew this freehand, right? It's not a straight line, it's not linear. So this height is dependent on how I make that curve. If I change this curve and I go here, it gives me a different answer. If I go down here, it gives me a different answer. So because of that, we can't rely on the graph to get an accurate height at 78 seconds. We therefore require an equation. So the last lesson we talked about our equations and what we require. So we need the period, equation of the axis, amplitude, and then phase shift. So peeps, if you remember from previous lesson. So the first thing is the period. We start at 10 seconds, we end at 100. So from 10 to 100 is a total of 90 seconds. Now, one thing to remember is in order to get the equation, we have to determine the K value. And K is equal to 360 divided by the period, which is 90, which will give us a K value of 4. The equation of the axis is the middle of my graph. So again, we can just look and find it, or max plus min divided by 2. So the equation of the axis is at 6 meters. And then from 6, that's the middle of my graph, to my maximum point, or to my minimum point, the amplitude is 5 meters. Now in lesson 6.6, we really didn't deal with the phase shift because all of our graphs started at the y-axis. But what we notice here in this situation is that my graph does not start at the y-axis. It starts at 10 seconds. So because I'm not starting here at the y-axis, there's a phase shift involved. And my phase shift is that I am 10 seconds to the right. Right? Because my graph doesn't start at the y-axis, it's been shifted over 10 seconds. So that is where my phase shift comes from, because I'm not starting right at the y-axis. So now that I have the peeps, I can determine my equation. So y equals amplitude. And because I'm starting at a maximum point, it's going to be a coast curve. K value 4. I'll use t for my independent variable. 10 seconds to the right. So it'll be t minus 10. And then my equation of the axis, which is 6. And we have the equation. Now that we have the equation, we can determine John's height at 78 seconds. So at 78 seconds, t equals 78. So y equals 5 cos 4, 78 minus 10, plus 6. Now you could type all that into your calculator in one shot, making sure you use your brackets properly, or we can just simplify this first. So y equals 5 cos, that becomes 272, plus 6. Now making sure that your calculator is still in degrees, you can type that in exactly as you see it, and we get an answer of 6.2 meters. So therefore, at 78 seconds, John's height is 6.2 meters. So as you can see, 6.2, clearly different from what I initially determined here to be under 5 from my grid. So with all these, we draw our graph, we get a sketch, peeps, get our equation, take whatever we want to determine, sub it in for our independent variable, and we get our answer. So most questions are the same. We'll just look at one other one for this lesson. This one talks about Chantal swinging back and forth on a trapeze. Her distance from a vertical support beam in terms of time is modeled by a periodic function. At 1 second, she is the maximum distance from the beam at 12 meters. At 3 seconds, she's the minimum distance at 4. Determine the equation that describes her distance in relation to time. So I'll just do a brief sketch. 1 second, she's the maximum distance, which is at 12. At 3 seconds, she's the minimum distance, which is at 4. So again, just like before, they're only giving us half. So if that's 1 to 3 is 2 seconds. Another 2 seconds takes us to 5. And we come back up to 12. So we complete one full cycle. Period is from 1 to 5. So it's 4 seconds. To get the K value, 360 divided by 4. Equation of the axis, halfway between 4 and 12. 8, which means the amplitude would be 4. Right? From 8, we go 4 to get to 12. Subtract 4 to get to get down to 4. Phase shift, because we're starting at 1 rather than starting at the y-axis. phase shift is 1 second to the right. So we have all we need, y equals amplitude, cos, k value is 90. Again, because we're dealing with time, it'll be t minus 1 plus the equation of the axis, which is 8. And there's our equation. Now, the question didn't ask us for that, but let's say we want to determine Chantel's height at, could be past this. Why don't we determine her height at 9 seconds? So if t equals 9 seconds, then y equals 4 cos 90. 9 minus 1 plus 8. I simplify this. Y equals 4 cos 9 times 8 is 720. Plus 8. And put that into our calculator. 4 cos 720 plus 8 gives an answer of 12. So she would be at her maximum height of 12 meters at 9 seconds. Which again makes sense. If she's going every 2 seconds, right? From 2 seconds at a minimum, 2 seconds at a maximum of 5, 2 seconds at a minimum of 7, another 2 seconds to a maximum of 12. So that's how you go about it. You would get your equation, sub a value in, and then simplify, put it into your calculator, and you get your answer. So some practice questions here, just 2 of them, page 398, question number 6 and question 8.